Good morning to all. I am Dr. Ganesh, Assistant Professor, Department of Aeronautical Engineering, Hindustan College of Engineering and Technology. So in this video, I am going to discuss about unsymmetrical bending. An outline of this video as follows: bending, types of bending, symmetrical bending, bending stress due to symmetrical bending, unsymmetrical bending, causes for unsymmetrical bending stress due to unsymmetrical bending, methods to find bending stress. Bending. Bending occurs when the structure is subjected to transverse load or moment at the ends. So in a beam, if the transverse load is applied, the bending will occur on a beam. Or if you are applying a moment at the ends of the beam, the bending will occur. Types of bending. There are two types of bending. First one is symmetrical bending, and the second one is unsymmetrical bending. Symmetrical bending. Symmetrical bending occurs when the plane of loading and the plane of bending lies on the principal centroidal axis. So if you are applying a vertical load that is lies on the centroidal y-axis, centroidal principal axis. So this will produce a moment above x-axis, that is mx. So this bending is called as symmetrical bending. Similarly, if you are applying a horizontal load about x-axis, that will produce a moment about y-axis. So this will also produce a bending about y-axis. Bending stress. Bending stress will produce when section is subjected to bending. The bending, it may be a symmetrical or unsymmetrical bending. Bending is denoted by sigma b, and the unit for that bending stress is Pascal or Newton per meter square. Bending stress. We know that bending equation from the solid mechanics is m by I is equal to sigma b by y is equal to E by R, where m is the bending moment, I is the moment of inertia, sigma b is the bending stress, y is the distance from neutral axis, E is the Young's modulus, and R is the radius of curvature. And from this bending equation, if you are rearranging the first two terms, you can derive the bending stress sigma b is equal to m by I is equal to y. So this is the basic equation for the bending stress due to symmetrical bending or as unsymmetrical bending. Bending stress due to symmetrical bending. If vertical load is applied on any cross section, it will produce a moment about x-axis, that is mx. Mx can be written as Vy into L, and we know that the basic equation of bending stress sigma v is equal to m by I into y. If you are substituting mx, so we can get the bending stress for this symmetrical bending when you are applying a vertical load, that is sigma b is equal to mx by ix into y. And bending stress due to symmetrical bending, if horizontal load is applied, that will produce a moment about y-axis, my. So my, the basic equation for bending stress is sigma b is equal to m by I into y, and my can be written as Vx into L. And the bending stress for the symmetrical bending due to horizontal load is given by sigma b is equal to my by Iy into x. Unsymmetrical bending. Unsymmetrical bending occurs when the plane of loading and the plane of bending does not lie on the principal centroidal axis. So if you are applying a horizontal and vertical load at the same time, so that will produce a moment about x-axis as well as y-axis, mx and my, and thus the bending it will not lie on the centroidal principal axis. That's causes for unsymmetrical bending. There are two causes for unsymmetrical bending. The first one is when inclined load or horizontal and vertical loads acts on a symmetrical section, the unsymmetrical bending will occur. For example, if you are applying a inclined load to x-axis as well as y-axis, so this produces a unsymmetrical bending on symmetric sections. The second one is when any loads, vertical load or horizontal load or inclined load acts on an unsymmetrical section that will produce a unsymmetrical bending. The first one, if you are applying a vertical load on a unsymmetrical section, this will produce unsymmetrical bending. If you are applying a horizontal load on an unsymmetrical section, this will produce unsymmetrical bending. Or if you are applying a inclined load on an unsymmetrical section, that will produce unsymmetrical bending. So any one of these load will produce unsymmetrical bending or unsymmetrical section. Bending stress due to unsymmetrical bending. If inclined load or vertical and horizontal load apply, unsymmetrical bending will occur. So the bending stress can be calculated by considering mx and my. So which leads to bending stress sigma b is equal to mx by ix into y plus my by iy into x. So this equation is regarding the symmetric bending. But when you are considering the unsymmetrical bending, the first bracket and second bracket will not be considered as mx, ix alone and my and iy alone. So there will be a combination of mx, my, ix, iy and ixy. So methods to find the bending stress for symmetric bending as well as unsymmetric bending. So we have three methods. The first method is K method, and the second method is principal axis method, and third method is neutral axis method. Thank you very much for watching this video. Thank you.